In order to solve a quadratic equation by factoring, we have to have something called the zero product principle, or some books call it the zero product property. So you'll hear me call it the zero product property a lot instead of principle. Same thing. Okay, this allows us to do the solving by factoring. And there's one key thing that you have to kind of keep in your mind before we start talking about the actual zero product principle. And that is the product of any number and zero is zero. So if I have 5 times 0, that just has to equal 0. And the reverse of that, like if we think, okay, I have this product that I know equals 0, what would those two factors be? Well, if you have a product of 0, at least one of the factors has to be 0. And that's exactly what the zero product principle is talking about. Okay. So the zero product principle says if the product of two algebraic expressions is 0, then at least one of the factors is equal to 0. So for example, if I had, I don't know, x times y equaling 0. Well, in order to have a 0 as a product, one of the factors at least has to be 0. So then x has to equal 0 or y has to equal 0. And that's exactly what this property is saying. So it basically says if I have a times b and I know that that product is 0, then either a is 0 or b is 0. One of the two has to be 0. And this property is absolutely essential when we're trying to solve quadratic equations by factoring. Okay, so let's go ahead and look at how we would apply this. We're going to take a quadratic equation that is already factored. Okay, so ordinarily we would have to factor first, but here we're going to look at like the last step. We've got a quadratic equation, it has been factored. How would we solve this by applying the zero product principle? So example 2 is exactly that. It says use the zero product principle to solve each equation. Well, for part A, I have two factors. My factors are x and x minus 2. Since the product is 0, at least one of the factors is 0. So x equals 0 or x minus 2 equals 0. So let's look at what happens when x is 0, and let's look at what happens when x minus 2 is 0. Okay, so what we do is we take each factor individually and set it equal to 0 and then solve. So we're going to say, okay, x equals 0, x minus 2 equals 0. Well, if x is 0, x is 0. But when you have x minus 2 is 0, go ahead and solve that for x and see what x would have to be. Well, in order to solve x minus 2 is 0, I would add 2 to both sides. Well, on the left, 2 minus 2 is just 0. X minus 0 is just x. And then 0 plus 2 is 2. So we're saying here the two solutions to this equation would have to be 0 and negative 2. And let's check them. So let's check x equals 0. Well, if x equals 0, I get 0 times 0 minus 2 equals 0. Well, 0 minus 2 is negative 2, but 0 times negative 2 is 0. So this one works, okay? Let's also check x equals 2. Well, if x equals 2, I would get 2 times 2 minus 2. Well, 2 minus 2 is what? 0. And 2 times 0 is 0. So we can say without a shadow of a doubt, both of these values really do satisfy the equation. So we want to write out our solution. And when you have a quadratic, you do write your solutions in set notation because we have two solutions. So set notation is where we have the little squiggly brackets, okay? And then you just write out your two solutions. Generally, you put them in order from smallest to largest, but I'm not going to get my drawers in a knot about that. But again, good form, you would write 0, comma, 2, and that would be your final answer. Okay, so applying the zero product principle is easy. You just take each individual factor, so each expression that's a factor, set it equal to 0, and then solve. Okay, so let's do the same thing for part B. So part B, we have two factors. Our factors are 2x minus 5 and x plus 4. And the product of those two factors is 0. So at least one of the factors has to equal 0. So let's look to see what happens when each factor is set equal to 0. So I first have 2x minus 5 is 0. Then I have x plus 4 is 0. I'm going to solve each of these individually for x. So 2x minus 5 is 0. I want to start by adding 5 to both sides. Well, on the left, 5 and negative 5 have a sum of 0. So negative 5 plus 5 is just 0. 0 plus 2x is 2x. And 0 plus 5 is 5. Now to get x alone, I need to undo the multiplication of 2 and x. So I divide both sides by 2. And I get x equals 5 halves. Well, we can check that. We can check to make sure it works. I would take 2 times 5 over 2 minus 5 times 5 over 2 plus 4. And I want to make sure that really does equal 0. Well, we're kind of running out of room here, but I promise you 2 times 5 over 2 is just 5. So I get 5 minus 5, and then I get 5 halves plus 5. Well, 5 halves is 2.5, plus 4 is 6.5. So I'm just going to write it as 6.5, even though we generally don't do that. We usually would keep it in fraction form. Well, 5 minus 5 is 0. So there's my 0 factor. 5 times 6, or 0 times 6.5 really is 0. So we know that this one works. It definitely satisfies the equation. Let's look at the second factor. We had x plus 4 equals 0. So in order to solve here for x, I would subtract 4. Well, 4 minus 4 is just 0. X plus 0 is just x. And 0 minus 4 is negative 4. But let's check it. Let's make sure it really works. So we want to take 2 times 4 minus 5. And then 4 plus, or negative 4. Hold on, let me rewrite that. I put a positive, not a negative. So x is negative 4. So we want to take 2 times negative 4 minus 5. Negative 4 plus 4. And hopefully that equals 0. If so, if we get that negative 4 satisfies the equation, it's also a solution. So let's see. 2 times negative 4 is negative 8 minus 5. Negative 4 plus 4 is just 0. Negative 8 minus 5 is negative 13. Negative 13 times 0 is 0. So this one also checks out. So we have two solutions here that satisfy the equation. So we would say our solution set is negative 4, comma, 5 halves, okay? And it just so happens later in this course, when we talk about graphing quadratic equations, we would notice that these also happen to be the x-intercepts. So that means this is the point where the graph crosses the x-axis. So don't forget that little nugget. It's going to come back when we get into a later chapter, okay? For now, just know these are the solutions to the equations. These are the two values that satisfy the equation, but they have this other really cool thing that comes up when we talk about the graph, okay? So at this point in time, make sure you know how to put a quadratic equation in standard form. Also know how to apply the zero product principle, okay?